So hello everyone, and this is the weekend today. So आज मैं यार I will upload the video early. So welcome back everyone to our another day of our GFG POTD streak of day 190. And if you are new to this channel, please like, share, and subscribe so that we can learn, maintain, and grow a streak together. Okay, so let us start with today's question. Today's question name is powerful integer, but I have read this question. I would have rated this question in a medium category, but I think the level of this GFG is growing up. Usually they are giving us the CP questions now. So ठीक है कोई बात नहीं. Let us start with the today's question. So we have been given a 2D integer array and the intervals are given with the start to and the inclusive. So we need to consider all the integers between the intervals as well as the start and the end integers. So powerful integers. We need to find a powerful integers, and a powerful integer is nothing but is that integer that occurs at least k times, and if multiple integers have at least k occurrences, then we have to return the maximum integer out of all the elements. Else if there is no integer occurs at least k times, then we have to return -1. So how can we do this? So let us write in the first test case as they have mentioned. Okay, so this is our day 190. Okay, so let us consider the ranges now. So the first range is from 1, 2 and 3. The second is 4, 5 and 6. The third is 3 and 4. So let us count that how many. One has occurred one time, 2 has occurred just once, 3 has occurred 2 times, now 4 has occurred twice, 5 has occurred just once, and 6 had occurred just once, right? And k is equals to 2. So that means we need to find all the integers which have occurred exact k times. So I can see that these are 2, right? So if there are more than one integer, then you have to return the maximum. So in 3 and 4, the maximum is 4, right? And we can get, as you can see, 3 and 4 are the two integers which have the two occurrences greater than equals to k. Very true. So that's why we have written the maximum, that is as 4. Okay, so the thing which I just showed you in the dry run, we can code this approach as well in this manner. How come? That we can make a map of integer and integer type, right? And we can push all the elements for all n intervals, for all n ranges, push the intervals, push start to end in map, right? And maintain the frequency. This will be the value and this will be this frequency, right? And at last we will just iterate in map. We will iterate in map, and we will find that if of all the elements which have the frequency greater than equals to k, and we will keep the track of the maximum, right? This would be the pseudocode. Now this was the brute force technique. This is the method one. What would be the time complexity of this code? That we will be maintaining a map, so space complexity will be definitely O of n to n, right? No, we are maintaining for each and every n there are intervals, and there can be for every intervals we are saving. So that means n into range, right? The maximum would be, and time complexity would be O of n into range again, right? Okay, please pause the video here and try to code it yourself. Meanwhile, I'll also code it and show it to you. And I'm telling you this video would be long because there are multiple approaches for this problem. I'll explain you 3 approaches. This is the first one. Let us proceed ahead now. Okay, as you can see, we have made a map here and hash map, as you can see. And for each and every intervals, we are iterating. For each and every number of intervals, we are actually iterating in the range, and then we are pushing it in the map. So this get the default function is nothing but it actually takes out the value, and if it's 0, then it do +1 there, right? Okay, then we have to just iterate in the map. We have this here. We stored the key and value in x and y, and if the value is the which is actually the frequency, if it is greater than equals to k, and then the answer, right? Answer is we have initialized -1 if it is less than equals to what, the key, right? Because we need to find the maximum, so we are maintaining the track of the maximum key which has the frequency greater than equals to k. So that is it. Let us compile and run, and we will see. So as you can see, the expected and our output matches. So let us see the constraint that would it get submitted or we will get the TLE. So we have n equals to 10 power 5 and the maximum possible range is 10 power 9, right? So let us get back to our open board and let us visualize. So the time complexity here we are using is n cross range, right? Because we have two nested for loop. So n is nothing but 10 power 5, range is nothing but 10 power 9, which you can clearly see it is greater than 10 power 8. And even if our code and logic is right, it will give us the TLE. Let us verify that as well, and then we'll proceed on with the next optimization. So I've clicked the submit button. Let us wait for the results. So as you can see that out of 10115, 10010 cases passed, and for the rest of the 5 cases, we have hit the upper bound of 10 power 8. Okay, so let us proceed ahead. So if you have, while studying the array section, if you have come across the prefix sum, right? Then that's a very standard question. You must have encountered this question while studying the prefix sum, right? And that is why I am saying that today it's a pure DSA question, right? Not at all rated to CP, but then I will rate it in a medium category, not in the easy one. Okay, let us see how the previous sum is working here, right? So let us define the ranges again. So we were having the ranges 1 to 3, 4 to 6, and 3 to 4, right? Okay. So what we are gonna do is that we will maintain an array, right? We will maintain an array, let's say 0, 1, 2, 3, 4, 5, 6, and 7. And what we will do is that this is the start range and this is the end range, right? So we will push in this array for each and every what to say interval. We will push the start pointer array of start plus plus, and we will push array of end plus 1 minus minus, right? So if we do this, what will happen that on this one we will get 1, and on this 4 we will get 1, and on this 3 we will get 1, right? Then let's come back to this second task which I just told you. So n plus 1, so 3 plus 1 it's 4, right? And we have to do minus 1, so 1 minus 1, which will convert it as 0 again. Then 6 plus 1 is nothing but 7, so 7 minus 1 it will give you as minus 1, right? Right. Okay, so it was plus 1 minus minus, so for this 7 it would be plus 1, and we have the minus 1. Okay, and for this 4 we will do plus 1, that is 5, and we will put minus 1 here, right? So rest of the entries will be filled by 0 0. Okay, so if I do the prefix sum here, what it would be converted to 0 1, this again the previous entry plus the current entry 0, then 0 plus 1 is again what, uh, this previous entry plus 1, and then previous entry plus 1, so it is 1, previous entry plus 1, that is 2, then again here 2, 2 minus 1 is 1, and then again 1, so 1 plus minus 1 will give you as 0, right? So this array is it's saying that the frequency of the element 1 in this range, in this entire range, is 1. Frequency of element 2 again is 1, and frequency of element 3 is 2. Let us verify that as well. So let us verify it as well. So this 1 and 3 will not, is nothing was representing the integer 1, 2, and 3, and this 4 to 6 representing the integer 4, 5, and 6, and again 3 and 4. You can clearly see that the frequency of 1 among these elements is just 1, right? And that's what it's representing here, right? Similarly, let us verify for 4. You can see 4 is here and 4 is here, so the frequency is 2, and you can see the 2 is here, right? Similarly, for any integer you can check, for let's say for 6, so it is 1, and you can see this 1 is here, right? So this is how this can be overcome using the prefix sum technique, right? Now what we need to do is that we need to implement an array of range size, right? O of range. The space complexity will be like this, but the range is, the max is 10 power 9, right? So that means even if we are able to code this solution, our time complexity for iterating, we will use a for loop, so iterating in this array, right? And whenever we see that the frequency is greater than equals to k, we will update this with I, right? So first of all, what will happen, that you will see there is a frequency is 2, right? So greater than equals to 2, and k was nothing but given as 2. So first answer will be iterated as 3, and then will be updated as 4. But for this thing we have to traverse in this entire array of 10 power 9. So the time complexity, the worst, would also be giving you as O of range, right? So we have converted from n into range to just range, right? So even so just a chance that if the constraint would have been just a little bit different, not the 10.9, if it would have been 10.7 or 8, then definitely this solution would have been get submitted, right? And that's an optimized one, so we have optimized very much in this thing, right? uh, what would be the space complexity? We have decided, and the triangle state will be over range. Please pause this video and code this solution, and then we will proceed ahead. So great, as you can see, we have declared our num equals to 10 power what, 10 power 345. We are declared as 10 power 5, although we must have declared as 10 power 9, but then int will not be able to handle 10 power 9, right? Let us see for 10 power 5, and then we will change it to 10 power 8 and 9 as well to see how the compilation reacts, right? We have answer equals to -1. Now we had this for loop to increment. We started the start as plus plus and the end as n plus 1 minus minus. Now we calculate the prefix sum here using this for loop. Prefix sum is happening here, and if we are just maintaining the track of the maximum value. An array of I is nothing but frequency of the element I, right? Okay, so we can see that the compilation has run successful. Let us hit the submit button and we will see how the TLE comes. So great, as you can see again 10110 cases pass, and again the 5 cases I have missed have been hit the TLE, and also you are getting the error that your this index is out of bounds, right? So clearly because we have declared 10 power 5 and the range is going to 10 power 9, but if I declared it as 10 power 9, let's say, so it is 5 zeros, right? So 1 2 3 4, then it will say that you have this thing, uh, you are out of space now because it cannot handle that much of what to say, the range, the overflow, right? So you have a Java heap space. So let us just exclude 1 0, and now we have made the array size length of 10 power 8, right? Okay, so now let us hit the submit button and let's see what happens. So I think we will again get the TLE, but let us see. Yeah, true. So we got the TLE, and this time only 10 cases passed, because for rest of the cases, since we have declared this as 10 power 8, so it is hitting the 10 power 8 bound and we are getting the TLE for most of the cases now. You may have observed that if we declare 10 power 5, then that is why the 10,100 cases were passed and only 5 cases were remaining. So I hope you are getting a good idea now how to see how to read the constraint, because it's a very important concept. I always tell you, either be you are in OA or in you are maybe doing competitive programming. OA in the sense online assessment, the first round which happened for the on-campus placement. So there you must see the constraint and then only use your time to code your approach, right? Because here I am teaching, explaining. That is why I am going from approach 1 to approach 3, because that's how you'll be able to get the logic, to think the logic of an efficient approach. Okay. So what can we optimize further in this solution? We have to think of that, right? So what I'm saying is that let us, how should I tell you? What I'm saying is, let this put entire thing in the map, and then I'll be able to explain it in more better way, right? Okay, so let us, one has the frequency as one. We'll do the same thing, not the frequency. We are doing again the start plus plus, right? And then we are doing end interval plus one minus minus, right? So if we follow that thing, then according to this interval mentioned here, 1 2 3 and all, right? So then 3 will be converted to, okay, and let's not convert it, let's write it. So uh, so we have 1, and then we have starting index as 4. So 4 will have, what say, I cannot see that test cases. So 1 3 4 6 3 4, right? mm, 1 2 3 4 to 6 3 to 4, right? Let me use a different color now. Okay, so it would be for this plus plus, and then 4 it would be again 1, then for 3 it would be again 1. Now we have an ending index also as 3, right? But we have to consider plus 1, so it would be 4, it would be 7, and it would be 5. So for 4 we have to do -1, so it would be again pointing to 0. And then for 7 we have to do -1, for 5 we have to do -1, right? So let me, okay. So let me write it in the sorted format. So 1, 3, 4, 5, and 7. What are the values? So 1 for 1, 3 for 1, 4 for 0, 5 for -1, and 7 for -1, right? And k was nothing but equals to 2. If I calculate the prefix sum here now, right? So it was 1, then it goes as 2, then 2 plus 0 is 2, 2 minus 1 is 1, and then 1 minus 1 is 0, right? Then you can clearly observe what it is saying is that the frequency of element 1 is nothing but 1. Frequency of element 3 is nothing but 2. This is the prefix sum is showing, right? You can clearly observe that as well, right? Uh, using this array, and using this map, Treemap actually, right? Why Treemap? Because we need things in the sorted format. It will make sense. Let me go through the solution once. Okay, so we have this thing now, right? And we will check the same thing, right? Here we will check that if the let's say this value, if it is greater than equals to k, then update it in our answer, right? So we check for this entry first of all. So the value, the prefix sum was pointing to 1, right? For this entry, the answer will be updated to now 3 because it is greater than equals to k, because k was nothing but equals to 2. Then the answer will be updated as, since again it is 2, it will be updated as 4. Now it has come to 1, which is less than equals to 2, so it will not be updated. The answer will still remain 4, and the answer will still remain 4, and we can return the answer, right? Yeah, return the answer. But you can clearly, आप सोच रहे हो ऐसा है कि नहीं, इसमें कुछ तो missing है. What is the missing part is that we have to consider the range and not only the starting and ending integers, right? You can clearly see कि यहाँ पे 6 भी consider हो रहा था, right? And but in this map you cannot see 6 as an answer. तो अगर k equals to 1 होता, right? अगर k equals to 1 होता, then what would have been the case कि यहाँ पे answer update होता सबसे पहले as 1, right? Then यहाँ पे prefix sum 2 है, then answer would have been updated as 3, right? फिर यहाँ पे prefix sum again 2 है, the answer would have been updated as 4 because we need the maximum, right? Then prefix sum यहाँ पे 2 हो गया, which is again greater than equals to 1, the answer would be updated as 5. And again यहाँ पे 0 हो गया, so the answer would not be updated and it remains same 5. But you can clearly see that if you dry run it, the answer should be 6 for k equals to 1, right? Because we have to consider the integers in the range as well. तो इसका क्या मतलब है यार? इसका मतलब ये है कि whenever we are comparing, यहाँ पे ना आप दो if cases लाएंगे, आप बहुत ध्यान से समझना. That is the trickiest part, right? तो यहाँ पे ये होगा कि if जो यहाँ पे जो ट्री मैप बना, अगर if value is let's say greater than equals to 0, right? Then what we need to do is we need to add prefix sum as it is. Prefix sum plus equals to what to say. This is the x row and this is the y row. So we will say prefix sum plus equals to y, and we will check if my prefix sum is greater than equals to k, then I will update my answer. So answer will be nothing but the key, right? ये पहला if तो बहुत easy है, right? बट यहाँ पे हमें एक और if डालना होगा, और लेट्स से यहाँ पे एक else if डालना होगा जो हमारे वैल्यू लेस देन 0 को चेक करेगा, ठीक है? So how it is working, let me write that as well. So if that's the case, then what you have to do, then you have to first check that if ps is greater than equals to k, then answer is nothing but x minus 1. Why x minus 1? Because what we were doing when we were putting the values, we were always doing n plus 1, right? तो हमें जो वैल्यू है वो x minus 1 से निकालना होगा, और हमें ps plus equals to y ये यहाँ पे करना पड़ेगा. ये समझना जरूरी है यार, यहाँ पे पहले क्यों किया और यहाँ पे बाद में क्यों किया, राइट? मैं बताता हूँ क्यों किया. अगर k equals to 1 होता है तो आंसर यहाँ पे 6 होता है. आप एग्री कर रहे हो, है ना? You can try run the test case and you can see from this array as well. अगर k equals to 1 होता, then the maximum element which has the frequency as 1 is 6 here, right? ठीक है. बट इस मैप में तो 6 एंट्री नहीं है, तो हम वो कैसे चेक करें? तो हमें इस तरह से चेक करना होगा इसे. लेट मी राइट इट अगेन सो दैट आई कैन tell you. So for 1 we have 1, so for 3 we have 1, and for 4 we have 0, for 5 we have minus 1, and for 7 we again have minus 1, right? ठीक है. तो यहाँ पर क्या होगा, ये हो गया हमारा x, ये हो गया y, हमारा ps की वैल्यू हो गई ये 1, राइट? और वैल्यू जो है वो क्या है, ग्रेटर देन इक्वल्स टू 0 है. फॉर दिस केस इट्स 1, राइट? तो हम वहाँ पे डायरेक्ट चेक कर लेंगे. पहले प्रीफिक्स सम को ऐड करेंगे एंड वी विल चेक इफ इट इज इक्वल्स टू k और नॉट, राइट? तो यहाँ पे हमारा जो आंसर है वो अपडेट हो जाएगा एज 1, राइट? 1, ये वाला 1, की वाला 1, ठीक है. नाउ अगेन फॉर द सेकंड एंट्री द वैल्यू इज अगेन ग्रेटर देन 0, तो हम सबसे पहले प्रीफिक्स सम ऐड करेंगे. एंड नाउ अगेन दिस 2 इज ग्रेटर देन इक्वल्स टू 1, राइट? तो हम यहाँ पे क्या करेंगे, आंसर हमारा हो जाएगा 3. फॉर दिस थर्ड एंट्री द वैल्यू इज इक्वल टू 0, तब भी कोई दिक्कत नहीं है. वी विल अगेन प्रीफिक्स सम इट, तो 2 हो जाएगा और वैल्यू हमारा आंसर हम हो जाएगा हमारा 4. नाउ द वैल्यू इज लेस देन 0, ठीक है? तो हमें यहाँ पे चेक करना होगा कुछ यार कि if prefix sum is 2, right? If it is greater than equals to k and k is nothing, in this case is 1, right? तो हमें क्या करना होगा कि for this index we have to take just एक पीछे वाला इंडेक्स लेना होगा, जस्ट पीछे वाला नंबर, दैट इज 5 minus 1 4. बट 4 हैज बीन ऑलरेडी अपडेटेड, तो यहाँ पे 4 अपडेट होगा, ठीक है? अब जब ये यहाँ पर आएगा, अब प्रीफिक्स सम हो चुका है 2 minus 1, दैट इज 1, राइट? पहले ये हुआ एंड देन ये हुआ, ठीक है? लास्ट एंट्री में अगेन द वैल्यू इज व्हाट, लेस देन 0, राइट? अब यहाँ पे समझ में आएगा कि 6 आंसर कैसे हो रहा है, राइट? तो तुम्हारे पास इंटरवल क्या थी, लेट्स से 5 से 7 में, तो तुम्हारे पास you have the 6 as well, right? तो इसका मतलब है कि व्हाट टू से हाँ, कि तुम्हें क्या चाहिए, मैक्स चाहिए, राइट। एंड यू कैन क्लियरली सी कि अगर हम प्रीफिक्स सम पहले कर दे, दैट इज 1 + 1 - 1 करके अगर 0 कर दे, तो क्लियरली हमारा प्रीफिक्स सम जो 7 के लिए 0 अपडेट हो जाएगा, जो कि हुआ भी था। यू कैन सी इन दिस एरे 7 के लिए 0 अपडेट हो गया था, राइट। बट ये अपडेट होने से पहले, ये जो 7 से पहले जितने भी एलिमेंट्स हैं और इस 5 के बाद जितने भी एलिमेंट्स हैं, उनका प्रीफिक्स सम तो 1 ही रहा होगा, है ना। यू कैन क्लियरली वेरीफाई हियर 5 से 7 के बीच में जितना भी प्रीफिक्स सम है उनका 1 ही रहा होगा, राइट। और हमें क्या चाहिए, मैक्स। सो दैट इज वाई हम जस्ट एक 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 इंडेक्स पीछे चेक कर लेंगे, राइट। फर्स्ट वी विल चेक that if ps is greater than equals to k, right, prefix sum is actually greater than equals to 1, it is verified. Now you take your answer as x minus 1, that is 7 minus 1 is 6, right, and you update your answer as 6, and now you update your prefix sum as prefix sum plus equals to whatever you have found, that is minus 1, right. So 1 minus 1 will give you the 0. समझ में आ गया ये बात, ठीक है। लेकिन एक और एग्जांपल देखेंगे यार, ये वीडियो लंबी हो रही है बट फिर भी एक और एग्जांपल देखेंगे, ठीक है। तो नाउ वी हैव द रेंज लेट्स से 16 to 21। हो सकता है कि एग्जांपल समझ में नहीं आया होगा, बोर्ड भी थोड़ा मेसी हो गया था। सो 12 to 17 and let's say you have 17 to 29। I have written this in my copy, let me write that as well, ठीक है। सो दिस इज द स्टार्ट, दिस इज द एंड, राइट। इस यहाँ पे एंड को सबसे पहले 1 से इंक्रीमेंट कर दो, 8 9 17 18। ऐसा क्यों कर रहे हैं यार, अगर ऐसा नहीं करोगे तो प्रीफिक्स सम वाली टेक्निक काम नहीं करेगी। 24 को 25 से अपडेट कर दो, ठीक है। हम ट्री मैप अब क्यों यूज कर रहे हैं आपको पता चला होगा, राइट, क्योंकि ये इंश्योर करता है कि सारे एंट्रीज जो है वो सॉर्टेड फॉर्म में हो। अगर हमने मैप यूज किया था तो हम ये इंश्योर नहीं कर सकते, हमें ईच एंड एवरी वैल्यू को चेक करना पड़ेगा, क्योंकि वो रैंडमली होते हैं। अगर सॉर्टेड है तो हम बस एक ऑर्डर में जाके चेक करना शुरू कर सकते हैं, राइट, बिकॉज वी नीड द मैक्सिमम, ठीक है। तो 5 के लिए मैं डायरेक्ट लिख देता हूँ यार, ठीक है। 5 के लिए इसकी ऑकरेंस 1 हो गई, स्टार्टिंग एंड इंडेक्स स्टार्टिंग, मैं इसको पहले सॉर्टेड फॉर्म में लिख देता हूँ। सो 5 9 12 16 17 18 22 एंड 25 एंड 30, ठीक है। तो तुरंत से कर लेते हैं। सो 16 के लिए क्या हो गया, +1, तो +1। 5 के लिए हो गया +1 ऑलरेडी मेंशन, 12 के लिए भी हो गया +1, 17 के लिए भी हो गया +1 और 9 के लिए भी हो गया +1। नाउ अगेन फॉर 22 वी हैव एज -1 और 9 यहाँ पर है तो अगेन -1 करेंगे। सो 1 - 1 विल गिव यू 0। 18 के लिए हम फिर से लिखेंगे -1, 30 के लिए लिखेंगे हम -1 और 25 के लिए लिखेंगे हम -1। आई होप यू आर गेटिंग दिस, ये कैसे हो रहा है, ठीक है। अब देखो प्रीफिक्स सम कैसे काम होगा, वैल्यू इज ग्रेटर देन इक्वल टू 0, तो प्रीफिक्स सम को अपडेट करते जाओ। और लेट्स से हमारे k का वैल्यू है यहाँ पे 3, ठीक है। तो प्रीफिक्स सम को अपडेट कर लो, यहाँ पे क्या हो जाएगा 1 एंड वैल्यू इज अगेन ग्रेटर देन इक्वल टू, तो प्रीफिक्स सम को पहले अपडेट करो एंड देन वी विल चेक। तो हो गया अगेन 1 एंड सिंस अभी भी ये ग्रेटर देन इक्वल टू 3 नहीं है, वैल्यू स्टिल ग्रेटर देन 0, तो अगेन प्रीफिक्स सम बनेगा पहले, अगेन ग्रेटर देन 0 तो प्रीफिक्स सम पहले बनाओ। अब नाउ k इज ग्रेटर देन इक्वल टू 3, तो हमारा आंसर अपडेट हो गया है 16 एज ऑफ नाउ, ठीक है। Now for 17 it is still greater than equals to 0, तो हमारा prefix sum हो गया 4 and the answer is updated as 17 now. Now the value is what, less than equals to 0, less than 0, right. Then what we need to do that we have to एक integer पहले का लेना होगा, right. So since the value is less than 0, तो हम इस हम previous PS से ही चेक करेंगे, क्योंकि आप समझ में आ रहा है ना कि हाँ ठीक है। तो 18 के लिए क्या होगा कि 18 - 1 आंसर अपडेट हो जाएगा अगेन एज 17 एंड नाउ द प्रीफिक्स सम विल बी कैलकुलेटेड एज 3। नाउ फॉर 22 दे, अब यहाँ पे बीच में इंटीजर्स है, राइट। वो कौन कौन से इंटीजर्स है यहाँ पे, वहाँ पे है हमारे पास 19 20 21। दिस इज प्रेजेंट इन दिस रेंज विच इज नॉट विजिबल टू अस एज ऑफ नाउ, राइट, ठीक है। और हमें पता है कि इनमें इनमें मैक्स कौन सा है, 21 है, राइट। सो दैट इज वाई हम इस की का हेल्प लेके जस्ट एक पीछे चले जाएंगे, ठीक है। और इस 21 के लिए प्रीफिक्स सम क्या होना चाहिए, 3 होना चाहिए, है ना, 2 नहीं होगा, क्योंकि 22 पे -1 हमने डाल रखा है, राइट। तो ठीक है, तो आई होप आपको समझ में आ रहा होगा यार बात, इसलिए मैंने दूसरा ड्राई रन भी दिखाया आपको। तो यहाँ पर क्या हो जाएगा, इट इज गेट लेस देन 0, तो इट विल बी कंपेयर्ड दैट इफ माई प्रीफिक्स सम इज ग्रेटर देन इक्वल्स टू k और नॉट, एंड प्रीफिक्स सम इज नथिंग बट 3, राइट। तो यहाँ पर हम उठाएंगे वापस से, अब हमारा अपडेट हो जाएगा वैल्यू एज 21, right, and now again the prefix sum will be updated at 3 - 1, that is 2, right। अब यहाँ पे again let's say 25 है, तो हम पहले चेक करेंगे बट prefix sum is already less than equals to k, तो prefix sum को वापस से अपडेट कर दो, आंसर will still remain as 21, so it would be 1 then it would be 0, right। यहाँ पे अगेन फिर से चेक हुआ लेस देन 0 है, तो अगेन यू कैन क्लियरली सी द प्रीफिक्स सम इज ऑलरेडी 1 व्हिच इज लेस देन इक्वल्स टू k, राइट? तो कोई अपडेट नहीं होगा, एंड देन अगेन योर प्रीफिक्स सम फाइनली विल बी 0 एंड यू विल हैव योर आंसर एज 21 फॉर दिस केस। ठीक है, आप चाहो तो आप इसको कस्टम इनपुट केस में डाल के आप चेक कर सकते हो, राइट? और आप देख सकते हो, राइट? ठीक है, so just for you, I have typed the same test case in the compiler and you can see that 21 is the answer, right? Similarly, आप अब आपको ये बात समझ में आ गई होगी कि हम ऐसा क्यों कर रहे हैं, right? So we are doing the same technique as I explained you using an array, right? The only optimization that we are doing is that we are not considering, हम एक ट्री मैप ऐसा बना रहे हैं जिसमें हम जो रेंजेस के अंदर जो एलिमेंट है हम उसको बिना लिखे किसी तरह हैंडल कर रहे हैं. So we are handling the elements in between those ranges as well without writing it, right? And how come that we are handling it like this, right? Because 18 से 22 के बीच में we know there are three integers but we need the maximum, right? So just just care about the maximum वरना बाकी को भूल जाते हैं, है कि नहीं? So again the optimization remains same. It's just that now we have used some lesser number of integers, right? So overall time complexity क्या हो जाएगी? In the map we are pushing the integers of the start, हम start को push कर रहे हैं and we are pushing the end integers, right? So O of 2n would be our time complexity, और since हम tree map में डाल रहे हैं तो push and pop का ऑपरेशन क्या हो जाएगा? वो जो sorting internal sorting maintain होती है उसके लिए extra log n लग जाएगा, right? So if we ignore the constant then the time complexity will be n log n and the space complexity will be nothing but O of what? We are using a tree map, right? So it will be 2n, right? ठीक है, तो यार हमने मेथड 1 देखा. अच्छा, ये समरी लास्ट में डिस्कस करेंगे. नाउ प्लीज पॉज दिस वीडियो एंड गिव योरसेल्फ 2 to 3 minutes and try to code this yourself, right? This is the entire logic, right? That how you have to iterate in the map and what you have to compare, right? Before this, please make a tree map, push all the integers. Start के लिए बस start plus push करना है, end के लिए n plus 1 minus minus push करना है, right? ठीक है, तो आई हैव रिटन द कोड हियर. और अगर आपको यार मेरे को नहीं पता आपको कैसा क्वेश्चन लग रहा है, इजी है मीडियम, बट यस आई हैव टू एक्सप्लेन ऑल द अप्रोचेस बिकॉज दैट्स द मेन मोटिव ऑफ लर्निंग, राइट? तो इसलिए मेरी वीडियो लंबी हो जाती है यार, मैं नहीं चाहता कि बस एक सोल्यूशन दूँ और काम खत्म हो जाए. वी नीड टू थिंक एज अ प्रॉब्लम सॉल्वर, राइट? सारे स्टेप्स आने चाहिए. क्यों किया ऐसा? ठीक है, so we have made a tree map of integer type. We have named this as map, and we have a for loop for pushing the integers of the start as start plus 1 and the end as end plus 1 minus minus, right? So we have a prefix sum variable as 0 and the answer as 0, right? So we will iterate in the map and we will store the key value pair. This key is nothing but actually the start and the end integers, and this y is nothing but the values, right? Values of the plus 1 and minus 1 for start and end respectively. So that's the exact pseudocode I explained to you, that if the value is greater than equals to 0, right, then first you have to calculate the prefix sum and then you have to compare. If it is less than 0, then you have to first compare and then calculate the prefix sum. That's the trick here. Yeah, this is the only trick, right? So this is a extension of our second optimized technique, right? तो अगर आप देखो यार, तो brute force अगर आप कर लेते हो ना, तो उन्हीं में से you have to analyze some repeating and eliminate those steps or optimize those steps. So I repeat again, I always repeat again in my videos, right? He do the brute force, see that what are the repeating and eliminate or optimize it. ठीक है यार, तो let us compile and then we'll hit the submit button for this code. So great, let us hit the submit button now. And now the complexity is just NlogN, right? So and constraint is 10 power 5. So if you place 10 power 5 into log of 10 power 5, it is definitely less than 10 power 8. And now it should or it must run. So let us wait. So as you can see, all the test cases has been passed successfully, and you can see attempts are like 4, but that's not the issue. While explaining, I have to submit multiple times for the brute force as well. Okay, so let us quickly decide the summary and then we'll move forward. So method 1 was that we see the brute force approach. We pushed all elements in map, right, in an unordered map. So n into range was the time complexity. The space complexity was also n into range, right? Method 1 we saw that we make an array of range, right? 10 power 5. We tried for making 10 power 5, 10 power 8 and 10 power 9. So 10 power 5, if we make an array 10 power 5, the number of test cases running for 11100, right? I guess only 5 cases were not successfully submitted. So O of range, and the time complexity was nothing but again O of range, right? Okay. And range was nothing but 10 power 9. So that is why it was also giving us the TLE, right? Method 3 was we used a tree map, and we pushed only the start and integers, and we internally handle all those elements that were the part of our range, right? I already explained you. Okay, so that is why it's the NlogN, and then the space complexity was also 2n, right? We pushed the end and the start integers. Okay, so you can see it was a very great journey, n into range to range and then NlogN. So this solution was finally getting submitted. So that is it for today's video. Let us meet again tomorrow in day 191. And if you are new to this channel, please like, share, and subscribe so that I can also be motivated to maintain our journey and make a good video again for you guys. So till then, keep learning, keep growing. Bye bye, and take care. And one last thing, that I don't think this code is also a very hectic one. Um, C++ users can uh, convert this code. It would be a very handy. Or also, I request any one of you guys to please convert this code in C++ and mention down below, because I have some time constraint. Okay, so it's 31 minutes video. Let us end this video here on a good note, and let's us meet tomorrow. Till then, keep learning, keep growing. Bye bye, and take care.